So today, in our challenge, when letter I, I'm talking about inductive proximity sensors. So sensors are the eyes of industrial automation. They are mounted in places to count, dictate, and verify the status of your automated systems. So today, we cover inductive sensors and their role in industrial applications and automation. Okay. In inductive proximity sensors detect the presence of metallic objects at close range. These sensors create an inductive field that reacts only to metal targets within their sensing zone. Parts and machine elements can be detected for purposes such as counting, indexing, verification, end of stroke or travel, determining orientation, and many other common automation tasks detectable. Detectable metals include iron, brass, aluminum, copper, and stainless steel. Iron provides the greatest sensing distance, while other metals require closer proximity. These sensors are low cost, reliable, and available in a wide variety of shapes and sizes for industrial applications. Whether round, rectangular, or square, all inductive proximity sensors operate on the same principle. Choosing the right sensor depends on a few criteria: sensing distance, size and shape, switching frequency, IP rating, mounting needs, correction factor, and weld slag resistance. The sensor body size and shielding type play a major role in determining sensing distances. In many applications, mounting the sensor close to the target isn't always possible. In these cases, a longer sensing range is often preferred. For example, in a furnace application, using a sensor with an extended sensing distance may reduce the need for more costly high temperature models. Placing the sensor farther from heat source helps minimize thermal stress, which can lower maintenance needs and extend the sensor's service life. There are two main types of inductive proximity sensors. We have the shielded and the unshielded proximity sensors. A shielded or flush-mounted sensor can be mounted with the sensing face level to the surface. An unshielded or non-flush mounted requires a metal free zone around each sensing face to avoid interference. What's the trade-off? Unshielded sensors typically offer a greater sensing range. For example, a standard 8mm flush mount sensor might have a sensing distance of 1.5 millimeters. Compare that to a non-flush mount version in the same family. It extends to 2.5 millimeters. Mounting styles can also vary. Non-flush sensors provide the longest sensing range but require the most clearance. Semi-flush sensors need less clearance and offer moderate range. Flush sensors allow the most flexible mounting with the least interference, but with a shorter sensing distance. Every inductive proximity sensor also has a specified switching frequency. This is the fastest rate the sensor's output can transition between on and off states. For most applications, the speed is more than enough to handle normal operations. But if you're working with very fast moving parts or using the sensor in a tachometer application, it's worth paying attention to the switching frequency to make sure your sensor can keep up. Maybe you have a slower moving application with a small gap between parts. You will need a high switching frequency for a fast on-off on cycle to detect all the parts coming through the sensor. Inductive proximity sensors are most sensitive to ferrous metals like iron. When you're detecting non-ferrous metals such as aluminum or stainless steel, the sensing distance is reduced. This is called the correction factor or K factor. Some sensors are designed with a K factor of 1, meaning they can detect all metals at the same distance, so they don't have to worry about adjusting for different materials. You also want to consider the environment your sensor will be and select one with the appropriate IP rating, ensuring it can stand up to the system's conditions. Finally, some sensors are specially designed for automated welding applications. These sensors carry a slag metal rating, are weld field immune, and are some of the hardest in the family to survive the harsh conditions in welding applications. So having seen the details of inductive proximity sensors and their applications, we'll now move over to the next letter, J, in our challenge. So guess the instrument that would form the next topic. I'll see you on the next one.